for the metabolome analysis. So, based on the metabolite analysis, we obtained around 1200, that in the around 1100 in the mature green, and around 1200 differentially accumulated metabolites in the red ripe. This comparison is between the resistance against the susceptible parent, the susceptible line. Okay, and here we can see that is in the PCA there is a clear separation by the genotype and stage. So these are the resistance, and this is the resistant genotype, and this is the susceptible. And also we observed that based on the stages there were difference on the metabolome. So here, this is the main different metabolites species, classes that were differentially accumulated. Here we have the mature green stage. One of them was the lycoperoxide C that was highly upregulated or accumulated, sorry. And this also metabolite was on the red ripe stage. We will see further what are the main function of this lycoperoxide C. Among the non-regulated metabolites, we have the exclusion A and exclusion B. These are the main compounds that are coming from the alpha-tomatin pathway as the fruit ripens. And there were also tomatin compounds related from the alpha-tomatin, that, as we know, alpha-tomatin is one of the main compounds helping tomato in the plant defense. So later, we wanted to see what are the pathways that are associated with these metabolites, and we obtained 3 pathways that are mostly related to these metabolites associated with plant defense. Is the flavonoid biosynthesis, phenylpropanoid, and also the stilbenoid and gingerol biosynthesis. Among the flavonoids, we obtained different compounds, was the pleurosin, butene, and arginine, beta-glucoside. These have been reported before as antimicrobial and antioxidant and signaling function in plant defense. And in the phenylpropanoid pathway, we have the chlorogenic acid and also the caffeoxychymyl acid. These ones are related to the lignin biosynthesis and also to the cell wall fortification that in our study, it may infer that this has this cell wall resistance that it doesn't allow the fungus to penetrate. So we wanted to also associate what are the genetic factors that we already published in another study, in a previous study in 2023. And we wanted to compare the pathway level between the genes and the metabolites. And in the end, we came with 2 pathways that there were enriched pathways. This is the phenylpropanoid biosynthesis again, and the flavonoid biosynthesis. These are the main associated differentially metabolites, accumulated metabolites that we already discussed about them. And among these one, there were these 2 genes that are located in the chromosome 6 and chromosome 11. Both of them are annotated as a protein hydroxycinnamyl transferase. This one participates on the flavonoid signalase to produce flavonoid compounds for plant defense. So in the end, we remain with 3 basic compounds. One was the lactopers C, that is the product of the sequential glycosylation in the alpha-tomatin pathway. And these ones are mainly related for the UDP glucosyl transferase. That is, these ones are just glycosylating and making more stable these compounds. We have the chlorogenic acid that also has been reported to different resistant to the necrotrophic pathogen, like again the Colotetrachium, Botrytis, and the Alternarium. And we have this aspartame that is flavonoid that is primarily reported in the citrus systems, and they appear around the 6 days after the infection with Colotetrachium glaspirids. So based on these compounds, as you can see, there is a high change between the resistant and the susceptible, and these compounds may referring that the infection does not occur in the resistant genotype. So why we focus on the lycopene C? As you can see, here is the alpha-tomatin pathway and how it's glycosylated until the end. We have the glycoside A. The alpha-tomatin is a toxic compound. It is consumed in high quantities in humans, but when it changes to the ripened stage, the glycosides are not toxic to the humans. But this is the normal way that happens on the cultivars. This goes from the alpha-tomatin to the glycosides. But here there is a branch from where these alpha-tomatin compounds, they doesn't go to the glycoside A, but it comes to the leucoperoxide C. That is mainly our main compounds that is related to the resistance. So conclusions. We have the metabolic profiling reveal the different defenses.